Hello. Hi everyone, welcome to this new edition of PHP Sussex. Thank you all for coming. My name is Yannick, and if this is your first time at PHP Sussex, we are a Brighton-based user group dedicated to the PHP programming language and to web development in general. We gather roughly every other month, usually on the second Wednesday of the month. We've got a couple of talks for you tonight. The first one is a lightning talk about the imposter syndrome, which I'm sure we've all experienced at some point in our careers. It will be given by Adria Figueres, who is a software engineer at Tilo. He will be followed by Dan Johnson, who is the head of engineering at TRYBE, for a talk about character encoding. And after all of this, we will be headed to the pub to prolong the conversation. Before we do any of this, though, first a reminder that this event is recorded. So if you do not want to be filmed or photographed, please do let us know. And then before we get started with the talks, Cameron is going to tell us a few words about Silicon Brighton, Runway East, and Tilo, who kindly support this meetup tonight.
Sweet.
Over to you, Cameron.
Thank you very much, Yannick. And the clicker is working, and I've got it the right way up. Usually I go backwards. Hey everyone, my name's Cameron. I work for Silicon Brighton, who are the hosts of I always say Silicon Brighton before Brighton. Brighton and Hove's tech sector. Much like PHP, we run, not much like PHP, we run a lot of different meetups across Brighton and Hove in the digital tech network, and PHP is one of them. We have fantastic sponsors in Runway East who sort us out for the pizza this evening, which is fantastic, and also Tilo is also a sponsor, and I'll get onto that in a little while. Here's some of the meetups that we support. We've actually recently started with WordUp again. They had their first meetup for probably like 6 months yesterday. So if you're interested in WordUp at all, or WordPress, that's the one to go for. We've got groups that specialize in asynchronous programming, AWS, breaking breadboards as well, who are like our robotics kind of group. That, I heard someone talk about Arduinos earlier. That's the place to go. There's a lot of 3D printing of robots and things like that. So that's all on our YouTube channel, which we're streaming to as well, if you want to check that out. We are a not-for-profit. We're supported by loads of local businesses, Tilo included. Tilo sponsored PHP, as well as Silicon Brighton as well. So we're massively appreciative of Tilo. And all of these local companies, if you're new to the area or looking for your next role, one of these companies could be a fantastic place to reach out to. We also are sponsored heavily in our yearly budgets as well by James Chase, Plus Accounting, More Law, Alirity, and we also put on our own conference called the Evolve Conference, which we hosted at the Dome. Quick show of hands, was anyone at Evolve? Decent, there we go. I saw you there, Yannick. But yeah, so not only do we run our own conferences, we also assist with other conferences as well. EARL is the Enterprising Applications of the R and Pi programming languages, and there's a discount code there if you want to jump on the QR code, if you're interested in that at all. You can stay up to date on all of our activity via this QR code. We've got a fantastic Slack channel which goes into all the different communities as well as broader events as well, all for linking you up with the digital tech network in Brighton and Hove. As I have already laid bare, we are sponsored by Tilo this evening, and we're incredibly gracious for that. I don't think there's any particular announcements for Tilo, not today, but so thank you, Tilo, for purchasing the drinks this evening. They've gone down really well. And then I think that's my last one. So thank you very much, Yannick.
Thank you very much, Cameron. So yeah, let's move on straight away to the first talk of the evening. So yeah, please welcome Adria for his talk, Debugging Self-Doubt, Beating Imposter Syndrome.
Hello everyone, good afternoon. I'm very grateful and very honored to be here today. Thank you for the opportunity. And as Yannick said, I'm Adria Figueres, I'm from Spain. I've been a software engineer for almost 8 years now. And today we are going to talk about the elephant in the room that many of us quietly wrestles with every day, and it's the imposter syndrome. Also, we are going to learn how to debug it and how to beat it. It doesn't matter if we are software engineers, if we are product managers, if we are designers, or even if we are CEOs of a successful company. This fear transcends roles and careers. So this fear transcends everything, basically. It affects us all. In order to know what we are facing against, we need to define first what is the imposter syndrome. Whenever we feel that we are not good enough, that we are not as competent as others might think we are suffering from the imposter syndrome. Whenever we feel that we are faking it, that someone might expose us to society someday, or maybe that we are not fitting in, that we don't belong here, that we want to escape or run, we are suffering from the imposter syndrome. And the imposter syndrome is not only about self-doubt. It's a feeling that is constantly evolving into more negative feelings, creating the downward spiral of negative thoughts. Let's put an example. We have pushed a bug to production, and now we are scared of doing more mistakes. And now maybe we start thinking about our manager, our boss, what he's going to say. And what about the others? And what if we get fired? So this creates the snowball effect of negative thoughts that we need to avoid at total cost. So having said that, I want to ask you if you could raise your hands if you ever felt that way before. So don't worry, because we are not done. Even Peter Parker himself experienced the imposter syndrome while defending New York City from villains. The boy who lived always thought that he wasn't living up to the expectations of others about being the chosen one. Even Elsa isolated herself from her society because she thought she wasn't being the perfect queen. And even the savior of Middle Earth couldn't do it alone either. But this doesn't affect only fictional characters. I have plenty of experience myself. As a Spanish guy, 3 years ago in a new country, with a language barrier, with no friends, every conversation felt like a test for me. Also, if we add the pressure to succeed quickly, because the immigrant mindset tends to, or tries to, overperform because it thinks that it needs to compensate for what it's lacking. And also cultural differences at work, just different ways of doing things. So now that we have defined what is the imposter syndrome, we need to understand why does this happen. Even though each one of us have our own personal reasons, there are common patterns that we can easily identify. The first one is the constant need to keep learning. In this high-paced world, even more in tech, we are constantly reminded that we need to stay updated, to learn that latest framework, that newest language. And while we are trying to deliver for our company's value with tight deadlines, pressure, and sometimes it's easy to think that we are falling short. Also, comparing with others doesn't help at all. Again, in this hyper-competitive world, we sometimes end up on LinkedIn checking latest news, latest trends, and finally checking brilliant profiles with brilliant careers and brilliant companies. And again, it's easy to think that we are not enough. Then we have that the reality is corrupted. Or I might say that the reality we consume is corrupted, because these days we see a lot of perfect code snippets on LinkedIn, for example, flawless project launches, and people announcing promotions. But what we don't see are the amount of bugs that they have created in the process, the amount of failed project launches, and the amount of anxiety and pressure that these people felt before the promotion. And our latest addition to the stack, AI. I know that AI helps us a lot in our daily basis, but everything has a trade-off in life, because I guess that you have heard already the motto, AI will replace you. And this is not good for our mindset either. So now, how can we know if we are already experiencing the imposter syndrome? What are the symptoms? The first and most common one is downplaying our achievements. No matter how well we do our job, we still think that it could do better, we could do better. So this is completely normal because the brain is wired in a way that it takes more into consideration negative things rather than the positive ones. It's just a matter of evolution. Let's put an example of this goalkeeper. This guy has been saving his team for 3 matches in a row, and no one is noticing it. But the next match, he fails, he makes a mistake, and the next day, he is on the front of every newspaper. He's criticized. So we don't need to go to this extreme use case. Think about a day in our lives at the office. We are having a good day, then we have a meeting, and someone says something that we don't like. We just think about that conversation, no matter how well was the day going. So when we start walking the path of negativism, we start walking the path of perfectionism, which is the path of inaction, overthinking, and eventually the path of having a worse performance. And the moment we realize that we are having a worse performance, we get stressed. Second one is the fear of being exposed. Sometimes we miss chances of growth because we are afraid of failure, and it's completely normal, but we miss chances of asking a question in a meeting. We miss chances maybe disagreeing with your manager or discussing something with your manager. We miss chances of growth because we want to do a talk, but we are non-native speakers. And then we have burnout, a very popular word these days. Do you know that almost 75% of IT professionals suffer from burnout at least once in their lifetimes? It happens when we try to over-deliver and overcompensate, and we felt like we are being drowned from our mental, physically, and emotionally forces. And I know what you're saying, Adria. You're stressing me out with all this negativity. But don't worry, because we are here because we want to debug the self-doubt and beat the imposter syndrome. So how can we prevent it from happening? The first and most important thing is knowing ourselves, knowing our limits, knowing our triggers, knowing our inner signals. So the moment we start feeling them, we need to pause, meditate, and rest. That's it. So we will avoid burnout. The second one is the release of judgment. Or I might say, stop caring about what others might think about us. I know that this is easier said than done, but if we can do that, we will build a healthier relationship with criticism. And the latest one, which is super underrated amongst the population, is maintain balance in your life. When work and personal life are in harmony, we safeguard ourselves against the imposter syndrome, and this is a huge amount of stress. So how can we debug it and beat it if we are already experiencing it? The thing that works best for me is having reality checks. Taking accountability of our wins in life helps us a lot in those moments that we feel that we are on a free fall. In those moments, we need to read all our wins in life, zoom out our life, and get the bigger picture, and we will realize that we are not that bad. We are way better than 5 years ago, let's say. I literally have notes in my mobile phone when I can read my wins, just in case that I'm having a bad day. Second one is setting smart expectations. By setting specific, measurable, achievable, relevant, and time-bound expectations, we are protecting in a very safe way from the imposter syndrome. which is the same as saying setting realistic expectations. If tomorrow I decide that I want to be an NBA player in 6 months' time, I will start experiencing the imposter syndrome from day one, because I know that it's impossible for me, because I know my limits and I know that it's unrealistic. But if I want to learn Kubernetes in 6 months' time, I know I can do it. The third one might be a bit controversial, but we need to look fear in the eye sometimes. We usually tend to avoid the problem, thinking that those problems will disappear magically. But deep down, we know that problems grow in darkness. So we need to be our own lights in life. And instead of avoiding the problem, we need to face the problem. And the moment we face the problem, we realize that the problem wasn't that big in the first place, and the problem shrinks. And this one is my favorite one, because it's translating a negative expression into a positive one. Have you ever realized that every time we experience the imposter syndrome is because we are doing something meaningful with our lives? We don't experience the imposter syndrome by watching Netflix or snoozing the alarm. So from now on, I suggest you to stop using the expression imposter syndrome and start using growth syndrome, because every time we experience is because we are growing as a personal, as a professionals, whatever. And I don't want to finish without giving you 2 quotes that they helped me a lot with this process. The first one, I've been listening to it my whole life from my father, which says, if you do everything you can, be calm. You are already doing everything you can. You cannot give the 120%, so stay relaxed and keep going. And the second one is one that I have discovered recently from Stephen Bartlett, that says, you belong in every room, you are brave enough to enter. Thanks.
Thank you very much, Adria. Are there any questions for Adria? And if you're watching this online, you can use the chat box to ask questions as well. Anybody has a question? Any question? What's that? Okay. I love your reframing of
Thanks.
The imposter syndrome into the growth syndrome. I've got a question, but it's a silly one. So you said at some point that at the beginning, when you moved here, every conversation is a test.
Yep.
I think the real test is, are you able to follow a conversation in a noisy pub? Because I've been here 10 years, I still can't.
Not really, if I'm
All right,
honest.
okay, I think that's perfectly normal.
Yeah.
All right, well, if there are no questions, then let's get another round of applause for Adria.
Thanks.
And we are going to move on to the second talk straight away. I'm going to let you some time to set yourself up.
Hello.
Good.
Oh, good.
Hello. First of all, thank you for doing this and taking the time. We truly appreciate it. So we met last year at Laravel Live UK,
Yep.
where you were giving a talk about localizing a Laravel application.
Yeah.
And then we had a chat at some point during the event, and I basically congratulated you on your delivery, which I think
Thank
was very welcome, and I think it's a sentiment that was shared by quite a few people. And based on this, I was essentially assuming that you were, really used to public speaking, right? And that's where you told me that actually you had never spoken at a meetup before, and you went straight to speaking at Laravel Live UK, which is, a conference, right?
Yeah.
And then you kind of explained to me how you made that happen, which I thought was a pretty cool story, which would be nice to share with the PHP Sussex community as well.
Yeah.
So how did you pull that off? Like, how did you go straight to speaking at the conference?
Yeah, so it was quite a crazy journey, really. I think it all started from when I was at Laracon EU a couple of years ago, and I always knew that I wanted to get into public speaking, but I'd never done it before and didn't really know how to get into it. So I just started talking to random people at the conference, and I just started to try and get my name out there. I remember speaking to Kaneko at Laracon EU, and he gave me some really great advice. He basically just said, you need to take every opportunity that you can get. So any opportunity that you're faced with, just go for it. And at Laracon EU, they had an event called the Unconference. So they've got like a little room in the conference where you can just do a lightning talk, and you don't have any time to prepare for it. So I thought, okay, this is my opportunity, I'm going to go for it. I did a 10-minute talk on localization in front of an audience of maybe 5 people, and thought, yeah, okay, this is good, I really want to do this. So then I just started applying for conferences, and I got really lucky by getting accepted to do a talk at Laravel Live London, and everything kind of snowballed from there. So I did my talk there. I loved being on stage. I really enjoyed it. And then from that, Casper, who is the organizer of Laravel Live Denmark, he was in the audience. He saw me and he said, I want you to come to Denmark to do a talk there. So then I did a talk there, and then I met Vishal from Laracon India. Then he invited me to come to Laracon India to do a talk. And then I did another one at Laravel Live London again, and then Copenhagen, and then a couple of meetups since then. So everything just snowballed, but I think it all started from just taking the opportunity and pushing myself out of the comfort zone.
Yeah, no, I think it's really a great story, and I think once again it shows also how far networking can take you as well.
Yeah, it really does.
No, it's really amazing. Okay, so you went to speak at Laracon India. How was it? Because I hear the atmosphere is crazy.
Oh, it was incredible. It's just so hard to describe. It's so different from any other Laravel conference that I've been to before. Everyone is just so friendly, and I mean they are friendly anyway at other conferences. But yeah, it's very high energy, and it was really interesting going there as well. I'd never been to India before, so it was a lot. Sure. Even just things like getting in an Uber and going to the venue, the driving is crazy there. So yeah, it was a really good experience. I loved it, and I'd love to go back again next year.
Yeah, because I saw some like footage of the conference, and there's like an MC, some DJs, some dancing going on.
Vishal was crazy. Vishal dances on stage. A couple of years ago, Taylor went and he was crowd surfing. The crowd are just so friendly, but everyone wants to get a selfie. Everyone wants to get your autograph. It's just, the crowd really wants to get involved with you. And it's a really fun experience.
I'm sure, it looked like a proper party at some point. Okay, so you went on to speak at other conferences as well. Any other ones on your radar at the moment? Are you programmed to any of them?
No, nothing on the radar yet. Okay. I'm going to Laracon Australia as an attendee. But yeah, I actually haven't applied for any of I know the Laracon EU CFP has opened up. I haven't applied for that yet, but fingers crossed.
I think you're allowed a break as well. You've been doing that a lot apparently. So, nice one. Well, Dan, thank you very much for your answers and for sharing your story. But I'm going to let you get on with your talk now.
Cool.
So please welcome Dan for his talk, Encoding Explained.
Thank you. All right, let me just find my mouse. Okay. Does that all work? Perfect. Okay, hello. So I guess I don't really need to introduce myself. You just heard that introduction there, but my name's Dan. I'm the head of engineering at a company called TRYBE. We make software for the spa and leisure industry. So it's software that manages your reservations, bookings, inventory, customers, and all of that stuff. And we do all that within a PHP application. And I'm from London. I've been down here. This is my second time here, so really grateful for the opportunity to speak here. Thank you to the organisers for inviting me up on stage. So I've been doing quite a lot of work at my company as the company's expanded, we've started to do a lot of work around internationalization, globalization, and localization, just as we've been expanding our product around the world. And with that, there's been a lot of fun challenges that I've been faced with. And I've learned a lot from that. And I don't know if you've seen my talk at Laravel Live London, but I spoke about how to build an application with localization in mind. And a lot of the things that I learned from that also involved character encodings. And character encodings have always been this thing that I've never really understood. It's just kind of a magic black box. Sometimes something doesn't work, and it's because of the character encodings, and you change it and things suddenly work again. And it was at one point when I realized I really need to understand what character encodings are, why we have so many of them. And I think that will help to understand why we have the issues that we do with character encodings. So this talk aims to describe what character encodings are, why we have so many of them, and hopefully open up that understanding for us so that we're not stuck with it in the future. Now, character encodings, it all boils down to how we interact with computers, how we give a computer input and how we receive output. So first of all, let's go on a bit of a history lesson, because this goes back to the ages of before computers, really. And it all starts with Keypunch Computing. So this here is an IBM 650 magnetic drum data processing machine. And these devices used punch cards to interact with the computer. So these were sheets of card with holes punched into them, and the holes would tell the computer the data. So these were developed in around the 1890s, and they used the physical representation of the holes on the paper to represent numbers, letters, and symbols. Now, punch cards had their first encoding. This was the first ever character encoding, and it was invented by this man here, Herman Hollerith. He was an American statistician from the 1800s. And he invented this punch card design where each column would be represented by a number. So if you wanted to feed a machine some information, some numbers, you would punch a hole in the card in a specific place. So if you wanted to punch number 5, you would do that on the 5 column, feed it to the computer, and the computer would understand, okay, you want a number 5. Now, there wasn't really a standard for this, and different machines used different versions depending on how thick the hole was punched in. But it didn't matter that there wasn't any standards, because you were just punching your cards for one machine, and you weren't sharing it between. There was no internet. Everything was fine. There didn't need to be a standard. Now, if we fast forward a little bit into the 70s, we had IBM. They created the standard 80-column punch card. So this was a bit more of a standard. It still used a Hollerith encoding, so we still had the same holes punched in to give the computer those instructions. But this was a standard, so now you could use these same punch cards in different computers and everything would still get understood. Now, these were 80 columns wide. Fun fact, when you open a terminal on your computer, the default size is 80 columns wide, and that's a throwback to these punch cards here. Now, punch cards were designed for batch processing. You would write your program on one of these stacks of sheets, and you would process that by passing it all into the computer, and then that would read the input, and then you'd get the output back, and then you would fix your errors and then repeat. So it'd be a really slow process. If you had bugs, then it would take a while to debug everything. It wasn't very interactive. And then as technology advanced, we started to see the rise of real-time input and output with screens and keyboards and mouses. And this was much faster for debugging and sending it data and getting it back. But there was one problem with this. Computers speak binary, and we humans don't speak binary. We speak in human language. And human language, that can be written in alphabet or scripts or other writing systems. So in order to make computers more accessible, we had to think, how can we do this? How can we get binary using our human language? So we came up with an idea to map binary sequences to alphabetical characters. Now, at the time, 7-bit computers were all the rage. So for a quick binary refresh, in a binary string, it can have one of two possible values. It can either be 0 or 1. And in 7 bits, you've got 7 combinations there. So you've got 2 to the power of 7. That's 128 possible combinations for one binary sequence in 7 bits. 128 combinations. The English alphabet has 26 characters. So we could map every character in the English alphabet to a number, and then we could use binary to represent that. So in the 60s, the American Standards Association, the ASA, they came up with a standard called ASCII, the American Standard Code for Information Interchange. And what they did here is they mapped every character in the alphabet, uppercase, lowercase, some numbers and some symbols, to a number. And they also mapped some control sequences for controlling the computer. Now, For this, you could send it the BEL command and the computer would make a bell sound. If you wanted to send it A, you would send it the binary representation, so that was 67 in decimal. Now these characters were carefully mapped out, so they kind of made sense when you look at them in binary. So this here is the null character. When we send it all the zeros, that means that we've reached the end of the string, the computer should stop listening. And this one is actually a throwback to when we had, back in the punch card days, we had punch tape computing as well, where the computer would read a reel of tape and the punched hole would be how it determines the input. If it sees a line of zeros, that means that nothing's been punched and it's the end of the input, it can stop reading. So they carried that over into ASCII. Now on the other end of the ASCII spectrum, we've got all of the ones, 1, 2, 7, and that's delete. That tells the computer that we can go back and delete the previous character. Now the alphabetic characters were arranged so that they kind of made sense when you look at them in binary. So if we look at the end here, it goes 1, then 2, then 3, then 4, then 5, all starting with a 1. And watch what happens to these first two parts of the sequence when we go to lowercase. It switches to a 1. So it's really easy to look at that and determine what the character is. And this was what all the nerds knew back in the day. They knew how to read these characters just by looking at the binary representation. So ASCII was a really clever way of reading language and sending it to a computer, but for American English anyway. Other languages, they started to develop their own character encodings that could support different alphabets or scripts. So most countries opted to base their character encodings off of ASCII because that made the most sense. Now, over here in the UK, we had ISO 646GB, and it was a copy of ASCII, but they replaced the American pound symbol over for the British pound symbol. So that meant that if you have a computer that's set to ISO 646GB, but it received a file that's in ASCII, everywhere where there was a pound sign would be replaced with the pound sign. It wasn't really a big deal. Now over in France, they had ISO 646FR, where they made two adjustments. So they replaced the pound sign, or the hashtag, with the accented A, and they also replaced the open brace with la cedilla. Now this still wasn't too much of a problem. If you opened up the file in the wrong character encoding, it would just be these two characters that would get confused and replaced with the wrong ones. But that was fine. It wasn't really that much of a big deal. Now, does anyone here remember Teletext? Yeah, so Teletext used its own character encoding, and again, it was based off of ASCII, but they replaced a few more of the sequences. So they replaced some of the symbols with things like blocks that could be used to make graphical representations. So that's how we got these beautiful graphics here. And they also replaced some of the control sequences. So instead of sending a bell, they could do things like make text bold or make text flash. So that's how they managed to get all of those teletext animations and graphics just by sending text over the air. Now the Soviets, who used the Cyrillic alphabet, they had to make some more drastic changes to the ASCII character encoding to make it suitable for their language. So they developed this character encoding, KOI7, and that replaced all of the Latin characters with Cyrillic ones. And because there are 36 characters in the Cyrillic alphabet, they also had to get rid of some symbols too. They even got rid of the $sign, and they replaced it with this thing here. This is the universal currency code. Now, in the 70s, we started to see the rise of 8-bit computers. So that means we get a whole extra bit here. That means that instead of 128 combinations, we've now got 256. So if we go back to that ASCII table, this here has 128 combinations, and this is perfect for 7-bit computers. But when you go up to 8 bits, you end up with all of this. You can't see it on this screen, sorry, but there's an extra 128 empty spaces in ASCII that are just ready to be used, and they're not being used for anything. So countries came up with their own character encodings to fill in all of these blank gaps that could be more suitable for their language. So this one here is CP437. This was developed by IBM, and it's based off of ASCII, but it uses all 256. So this is for 8-bit, and we can see that we've got our standard ASCII up here, but down here in all the blank spaces, they've added in all of these extra things. They've also replaced the control sequences with some symbols here, so you can play solitaire on your computer. And these ones down here, these are like what Teletext used, and this is what allowed early IBM computers to display graphical interfaces just by using text, all from this table of character encodings. Now, we haven't even talked about Asian languages yet. Over in Asia, their languages are a little bit more complex than ours. Now, Japanese, for instance, uses over 60,000 characters. So even with that one extra bit, that 128 extra spaces, there was no chance that we were going to fit in all of their characters in 8 bits. So we had to invent something different. And the Japanese invented dual byte coding. Now, one of these dual byte encodings that Japan invented was this one here. It was called Shift-JIS. And here's how it works. First of all, it was fully compatible with ASCII. So if you send it this binary sequence, the same as ASCII for a capital A, that would be understood as a capital A in Shift-JIS. It's fully backwards compatible with ASCII. But remember now that 8-bit ASCII, it had that table with the extra. We've got all of these extra gaps here. Well, what they did with Shift-JIS is they said if the first character was one of these, then the next character is a continuation byte. So that meant that if you put the lead byte together with another byte from the bottom of that ASCII table, those two together make one character. So essentially we're putting together 2 8 bits to make one character. And that gives us a lot more combinations. This meant that we've got 10,000 characters. Now that's still not enough for the whole Japanese character set, but that's enough to get by. So that's what they used, having 8 bits, but using 2 of them, and they can output any character there. Now, Japan actually had several different character encodings, and they couldn't agree on which one's which, so they kept on making more and more. We got Shift-JIS, EUC-JP, ISO22-JP, and Mac Japanese. And all of these were completely incompatible with one another because everyone had these different ideas and didn't want to agree on them. So that meant that if you wrote a file encoded in Shift-JIS and you put it on a floppy disk and you gave it to somebody and they opened it in ISO22-JP, they're not going to see anything. Everything's going to be completely garbled and nothing will make sense. Now, this was such a common problem for the Japanese that they actually invented a word for it, mojibake. I don't know if I'm pronouncing that correctly, but that means the characters are completely uninterpretable because of the character encoding. Now, you might end up seeing stuff like this. This here is the replacement character, and it means that the byte sequence was invalid. So when it tried to combine those 2 bytes, they didn't make sense for the character encoding, and then we end up with this character here. Now, you might also see these. These are called tofu blocks. So these usually mean that the character was capable of being encoded, but the font didn't have a glyph to output that particular character. Or you might just see a load of jumbled characters. That's where it could interpret the byte sequence, but it thought it was for a different character. But we just lived with that problem for a while. It wasn't too much of a problem. The workaround was switching the character encoding to something different until it worked. And this was only really a big problem in Japan or other languages where they had these multi-byte encoding systems. And transferring files between computers wasn't really that popular at the time because the internet wasn't a big thing. Well, that wasn't until the internet came about. Now, when the internet became a thing, now we had a big problem. Suddenly, people's documents or web pages were accessible all over the world, and people were writing these documents in different character sets, and people were reading them in different character sets. So garbled characters were a common sight in the early days of the internet. And we needed a solution for this. So in 1991, the Unicode Consortium came about to fix this problem. And what they did is they mapped out every character of every human language on the planet and assigned each character a unique code point, hence the name Unicode, unique code point. So they used 32 bits for this because there were so many characters that they needed to fit in. Now 32 bits, that's 4 bytes of binary sequences. So that gives us a theoretical maximum of 4 billion characters. Now in reality, Unicode only maps around 1 million of these, which is plenty for every human language. Now it's not just characters that they encode, they've also got some crazy stuff in there. They also encode emojis and even Egyptian hieroglyphs. There's some really crazy stuff in here, and I definitely recommend checking out what Unicode code points there are. Now we usually see code points represented like this, and you can't really see this, sorry, but this is U plus 1F4A9. This is the Unicode code point for the smiling pile of poo emoji. Now when we represent this as decimal, that gives us 128169. Now if we convert this decimal number to a binary sequence in 4 bytes, we end up with this here. And this is exactly how UTF-32 works. UTF-32 is 32 bits represented as 4 bytes, and this is how we render each character. Now, this is great because we can render anything in the Unicode code set, but there's a bit of a problem with this. We're using 32 bits, 4 bytes, for every character, and that results in massive file sizes compared to what we have with ASCII, where we're representing characters using just 8 bits. Now this is way less efficient than ASCII, especially considering the fact that when Unicode code points were assigned, everything in standard ASCII was brought across. So that means in Unicode, U plus 0041 translates to decimal 65, which is the same as ASCII capital A. So that means when we convert a capital A to UTF-32, it looks like this. We've got all of these zeros at the front because the character is only in that last bit there. So this is a real waste of file size. And in 1992, shortly after the release of Unicode 1.0, some smart guys, Ken Thompson and Rob Pike, met at a diner to discuss a solution to this. And they came up with UTF-8. They literally drew up the plans for this on the back of a napkin in the diner. Now, UTF-8 is a variable byte encoding system. Now, it's a bit similar to that Japanese byte encoding system that I showed you earlier, where they have 2 sequences joined together to make 1 character. But instead, with UTF-8, this can use up to 4, but it also can use 1 if the character fits in the ASCII set. And this is fully backwards compatible with ASCII. So if the first bit is a 0, this one here, the lead byte, then that means that it's ASCII and it doesn't need to go on any more than 1 byte. But for non-ASCII characters, UTF-8 follows a template. So we use the first byte to determine how many bytes we should use in total. Now, if the first character is a 0, then we know that it's only going to use up 1 binary sequence. If it's 2 bytes, if it starts with a 1-1, then we know that it's 2. If it starts with 1-1-1, then we know that there's going to be 3. If it starts with 1-1-1-1, then we know that there's going to be 4 here. So this is the way that the character encoding understands whether it should continue on or whether it should stop. So this one here, because there's a 0, it knows that it should stop after reading that one, and that's the character. So this means that we can reference Unicode code points in a much more efficient way. This here is the euro sign, and this can be represented just in 2 bytes because we've got the 1-1 here. And then if we look at the copyright symbol, this uses 3 because it starts with 1-1-1. Now UTF-8 is the de facto character encoding. It's used by over 95% of the web, and it allows us to represent any character. Well, that's as long as the font that we're using has a glyph for it. Because when a font designer designs a font, they have to map each glyph to a Unicode code point. Now, the more glyphs that they design a font for, the more compatible it is with different languages. But that also increases the font file size. So a font designed for rendering Latin characters might not include the glyphs for rendering Cyrillic characters. And then that means that you might end up with these tofu blocks. Now, Google are on a mission to eradicate these tofu blocks from the internet. So on Google Fonts, they've been developing a font called Noto Sans, which aims to map every Unicode code point. Hence the name Noto Sans, no tofu. That's why it's called Noto Sans. Okay, so how does this relate to us PHP engineers? Now, PHP has great support for UTF-8, but you may need to take extra care when you're working with non-ASCII characters. Now, have you ever wondered what the PHP MB extension does? Because this extension is a requirement for Laravel. Now, if you're using something like Laravel Herd or Cloud or Forge or Vapor for hosting, then this comes pre-installed for you. But if not, then you might need to install this PHP extension yourself if you're dealing with non-ASCII characters. Because MB string gives us a ton of functions specifically for dealing with multi-byte characters. MB, multi-byte. Now, let's take a look at some of the functions. So the first one that we'll talk about is mbstrlen. Now, this one's really handy for reading multi-byte characters, because if we want to determine the length of a string, usually we would reach for the strlen function in PHP. But if we hand that a multi-byte string, like this string here, hello in Japanese, this is going to give us 15. That's not what we want. We would expect 5 here because 1, 2, 3, 4, 5. The reason for this is strlen is counting the number of bytes that make up that string, whereas mbstrlen makes up for that UTF-8 string and works out how many code points there are. Now, you're probably thinking, this doesn't apply to me. I don't have Japanese in my code. But I bet you have emojis in your application. So if you're dealing with emojis, because those are mapped in the UTF-8 spectrum further down, they're not ASCII, most of the time, an emoji character will be 2 or more Unicode code points. So for example, this string here, if we did an strlen on this, we would get 35, because that's counting multiple for each one of these emoji. Now, if we do mbstrlen for this same string, we get 29, which is the value we would expect. So I'd recommend using this function here if you're doing things like you have a bio on your application where the customer can input some text and they can input emoji. And if you want to restrict the length of characters on that, you would want to use mbstrlen for that. Another handy one is MB check encoding. Now, when it comes to user input, you can't always be sure about what encoding you've been provided with. So let's say you've got a PHP application that allows users to upload a CSV file. Now, to avoid interpreting the file incorrectly, you can use the MB check encoding function to determine if it's in the encoding that you specify. So here, I want my application to always run in UTF-8 for consistency. Now, I'm opening my CSV file, and before I do anything, I'm going to check the character encoding. And if it's not in the character encoding that I expect, I'm going to throw an exception. Now, the MB string does also come with a function for detecting when your encoding is not what you would expect. But this function isn't very reliable, and it actually states this on the PHP website. This result is not accurate. The reason for this is because there's no real way of determining for sure what encoding a character is in. The only way that we can do this is by guessing. So the way that this function works, you can pass in an optional parameter to say, these are the character encodings that I'm expecting it to be. Is it one of these? And PHP will run through and try to determine, is it one of those? And this works quite well when you're using multi-byte encoding. So for example, with UTF-8, because UTF-8 has that specific sequence of continuation bytes, this method will check that that continuation byte sequence is valid, and if it's not, we know for sure that it's not UTF-8. But other than that, there isn't really a sure way of determining what a character set is encoded in, and that's because strings don't contain any metadata to tell us what the encoding is in. Now, if you do know the encoding it's in, MB extension comes with a method for determining how to convert it. So in this string here, we're saying we've got a request that we're accepting a file, and we know what the encoding is because the user's passed us that encoding. So we can use MB convert encoding here, and we can say we want it in UTF-8, and we're taking it from this specified encoding. So if you know what the encoding is, you can convert it using MB convert encoding. Okay, so let's sum up here. We have a lot of character encodings, and it's all thanks to legacy implementations and limitations. And lots of them are based off of ASCII, so a lot of the time you are going to see these base characters represented well, but once you start going into different characters, accented characters, that's when you might start to run in with problems with character encodings. Now, UTF-8 solves all of these problems, and unless you're working with very legacy systems or you've got very strict constraints around file size, you should always use UTF-8. strlen is probably not the function that you're looking for. You should use MB strlen instead to care for multi-byte characters. And you should always be consistent with your encoding. Use UTF-8 for everything. Use it for your database, your CMS, your translation service, and your PHP config and outputting files. And don't assume that your user content is always in UTF-8. And in order to avoid tofu blocks, you should use a font that includes all of the glyphs that you're expecting. So if your application is outputting Cyrillic characters, if your application is expecting Cyrillic characters, then you should use a font that's suitable for that. And that's all I have for you today. Thank you so much for listening, and I'd love to take any questions.
Thank you very much, Dan. Super interesting stuff. Yeah, it's definitely the kind of thing that we never stop to think about, is it, right?
Yeah, I know, yeah. I think that's exactly why I wanted to do this talk, because for so long it was just one of these magic things that I never thought about, and then once I dove into figuring out how it all works, and it just suddenly clicked and made sense.
Yeah, for sure, yeah. We just take it for granted.
Yeah.
So are you going to explain how character encoding works in quantum computing next then?
Far too complicated for me, sorry.
Because also you think with the zeros and the ones, I was like, how is that going to work?
Yeah.
Anyway, does anybody have a question? Yes. You're going to have to speak in the little thing, sorry.
I will try my best.
How do you approach finding out what character set that you've got in a file or in a database, because it can get really strange?
Yeah, and it's really tricky because strings don't come with metadata to tell you what encoding it is. So that's why the method that I showed you there, the MB check encoding, it doesn't have, there's no way that you can reliably determine that. The only way that you can determine it is if the file contains metadata to tell it. So for example, in a database, that, like a MySQL database, will store some metadata to say this is encoding in this character set. But yeah, if you've got
I've come across fields with one set and it's actually got something else in it.
And that's the tricky thing, and that's why the only solution to this really is to be consistent and always accept user data in UTF-8 and always expect UTF-8.
Very old database.
And with those systems, it's tricky.
Any other questions? So then again, if you're watching this online, you can use the chat box to ask questions. No questions? Sure. All right, let's get another round of applause for Dan. And we are going to wrap this up. So yeah, thanks again to Dan and Adria for the talks, and thanks again to the sponsors, Silicon Brighton, Runway East, and Tilo. We are going to head to the pub now, if you want, but if not, thanks again for coming, and see you in November. Take care.